Europa, one of Jupiter's major moons, has intrigued scientists and space enthusiasts alike. Though it shares a similar size to Earth's moon, its appearance is far more unique and mysterious. The moon's surface is strikingly smooth and bright white, dotted with dark lines and red patches. But what really draws attention is what lies beneath its icy surface. Scientists suspect that beneath the thick ice crust, Europa may contain a massive global ocean. This ocean could hold more water than Earth's oceans combined, raising exciting possibilities for life. Not only that, but it's believed the ocean may come into contact with Europa's rocky core. This interaction could provide the energy and chemicals required for life to thrive, if conditions are right. As an organic chemist, the idea of organic molecules forming there is especially thrilling. These molecules are essential to life, and if they exist on Europa, it could signal a major discovery. We already know that there's water on Europa, but the question is whether it's liquid and capable of supporting life. Water is one of the fundamental elements necessary for life, but its presence alone doesn't guarantee life exists. The question of whether life could be sustained on Europa is a subject of ongoing scientific interest. Recent findings have brought us closer to answering this question. For example, a magnetic signature detected during a flyby suggests that there's a subsurface ocean beneath Europa's icy surface. This magnetic reading is significant, as it implies the presence of currents similar to those in Earth's oceans. But while the evidence is mounting, there are challenges to life on Europa, many of them extreme. The surface of Europa is incredibly harsh, with temperatures plummeting to -160 degrees Celsius. This extreme cold would freeze most life forms that we know of on Earth. Additionally, Europa has no atmosphere, leaving it exposed to intense radiation from Jupiter's magnetosphere. This radiation is far stronger than what we experience on Earth and could destroy potential life. However, things might be very different beneath the thick ice shell that covers the moon. If life exists, it's more likely to be found in the protected subsurface ocean, away from harmful radiation and extreme temperatures. Tidal heating, caused by Europa's interaction with Jupiter, could generate enough warmth to sustain life. The ice may even act as a protective layer, preventing the harmful radiation from reaching the ocean. However, this thick ice, up to 30 kilometers deep, presents a challenge for exploration. Despite these obstacles, the potential for life beneath the ice remains an exciting prospect. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, gave us important insights into Europa's surface and atmosphere. Though it couldn't study the moon in detail, its flybys provided crucial data. More recently, the Hubble Space Telescope detected plumes of water vapor erupting from Europa's surface. This is an exciting discovery, as these plumes might give scientists the opportunity to study the ocean directly, without needing to drill through the ice. The Europa Clipper mission, set to launch in the 2020s, will conduct detailed flybys of Europa. This spacecraft will use a variety of instruments to study the surface, ice shell, and ocean of Europa. One of the main goals of the mission is to determine whether the moon has the conditions needed for life. The spacecraft will investigate whether Europa's surface ice contains organic molecules, which could be a sign of biological activity. It will also study the water vapor plumes, looking for organic compounds or other indicators of life. Scientists are also interested in the possibility of more complex life forms on Europa. Although microbial life is the most likely form, some researchers believe that complex ecosystems could exist there, supported by hydrothermal vents. On Earth, if similar vents exist on Europa's ocean floor, they could provide energy and nutrients for life. These vents could also release organic compounds into the water, supporting microbial life. The idea of complex life evolving in Europa's ocean is speculative but exciting, as it would deepen our understanding of how life can survive in extreme environments. If such life exists, it could offer a new model for life in other extreme environments, on other moons or planets. Europa is not just important for the possibility of life, it plays a key role in astrobiology. Astrobiologists study Europa to understand the conditions that could support life elsewhere in the universe. By learning about Europa's subsurface ocean, scientists hope to uncover the factors that make life possible. Europa serves as a model for exploring other distant worlds that might harbor life. In the far future, humanity might one day explore Europa firsthand. While this may seem like a distant goal, the technology developed for such missions could have broad applications in space exploration. A manned mission to Europa would present major challenges, including protecting astronauts from radiation and extreme cold. But such an endeavor would yield unprecedented insights into the potential for life on Europa and other celestial bodies. The exploration of Europa has profound implications, not just for answering whether life exists elsewhere, but for understanding the broader conditions that make life possible. As missions like Europa Clipper continue, we will gather more knowledge about Europa's potential for life and its role in the solar system. Ultimately, the exploration of Europa could help answer one of humanity's